So, hello everyone, welcome back again. Recently, we have completed alcohol, phenol, and ether, and again, I am available on my YouTube channel Govind Chemistry with new chapter and most important, you can say, in physical chemistry, thermodynamics. Okay, so thermodynamics is going to be very important chapter for us. Why it is important? Because it is in physics also and it is in chemistry also. Thermodynamics available in physics also, 11th physics, and this is 11th chemistry topic. Okay, in the first book, part 1, this is the chapter of physical chemistry, thermodynamics. Many times you have faced lots of problem in this chapter because it is little bit hard, but after the completion of this chapter here, if you are watching video on Govind chemistry, then definitely after the watching video there will be no problem in this kind of chapter, thermodynamics. I promised you. So from beginning to end you have to follow and start preparing notes. Your own notes are very important, so take your copy and pen and start writing. So once again, welcome back all my dear students, and here myself Govind, your chemistry mentor. Okay, so thermo means what, children? Thermo means what? Related to heat. Okay, dynamics means, erased. Dynamic means motion, something in motion. According to physics, two kinds of process are there, dynamic and static. Static means who is not working anything, and at the same position he is standing. But here it is heat in motion. If heat is flowing from higher temperature to lower temperature, this is the phenomena and this is the meaning of thermodynamics. So what are the content of this topic, children? We have to discuss about the heat here, we have to discuss about the work here, and different form of energy. What we will discuss? Different form of energy. So patiently, one more thing, this work and this heat is also a form of energy only. Then we'll move for the, if what is the process, which kind of process it is. Process is feasible. Feasible means it is happening by own without any external force, or not feasible, that also we will discuss. Heat change of heat, that we will discuss. In the gas process, gas means generally we will talk about the gaseous system. So gas, pressure, volume, temperature, enthalpy, entropy, internal energy, gives free energy, work done, all these things we are going to discuss here. Okay, so this is the content of this chapter which we have to discuss here. And now you have to stop all the work and focus here. Stop using electronic gadgets and focus on the mobile screen. So here I am erasing this. So children, what is the thing? The thing is thermodynamics. Not in thermodynamics, everything made by system plus surrounding, and combinedly they made universe. In the universe, two things are there. system and surrounding. Okay, now what is system, children, and what is surrounding? System is, according to the science, part under investigation. Suppose you are watching mobile today, this time you are watching my video on your mobile screen. So you and mobile screen is system. Except the system, all other thing, except the system, all other things are surrounding. In between system and surrounding, in between system and surrounding, boundary is there. What it's called? Boundary, which is classify system and surrounding. This is called boundary. Okay, so one more way of this explanation: system, just like it's don't take it otherwise, it's joke point of view. Suppose you are entering in the class and you are watching the girl which you like most. hmm? The girl which you like most, you are watching that girl. So you and that girl, that time is system, and remaining students are present. Whatever is there, everything is the surrounding. Then what is boundary, sir? Boundary is the other girl. In that particular class, other girls are also sitting, but you are not watching other girl. You are watching your system only. Huh? So don't take it otherwise. So that system and surrounding and boundary. So boundary classified into different category. Boundary may be real. Boundary may be real. Boundary may be imaginary. Imaginary boundary, how, sir? Just like river. In the river, river is a system. So in between the atmosphere, or you can say in between the world, there is a imaginary line between the river and the atmosphere. So that kind of wall, that kind of boundary is called imaginary boundary. Real boundary is very simple. Suppose, see, here I am telling you, here one container is given, vessel, huh? Sir, it's called vessel, I know. And in this container something is filled. Yes, liquid, whatever. So this is your real boundary, wall of the container. And here also no boundary is there, but it is a imaginary boundary. It is a imaginary boundary between the atmosphere, between the surrounding and the system. So it's a imaginary boundary. Boundary will be rigid. Boundary will be flexible also. Boundary will be dithermic, dithermic, you can say conducting. Boundary will be adiabatic. Now I am defining both, no need to confuse at all. Diathermic, children, diathermic is what? Across heat change easily. Heat can exchange easily. Across heat change easily. And adiabatic, in the adiabatic system, heat cannot flow. heat cannot flow. So it is made by insulating material, insulating material, and it is made by conducting material. Okay, so this is about the boundary. Okay, so this lecture is introductory lecture, children. Today I will give you the introduction of this chapter. Okay, so be with me now. Everything, each and every step I will explain. After my video, I guaranteed there will be no doubt in the thermodynamics, although it's a tough chapter. So types of system we are going to discuss. Types of system. So system classified into three kinds: open system, closed system, and isolated system. Okay, what is this, sir? Don't worry, one by one. Open system. In the open system, children, such a system such a system mass exchange plus energy exchange, both can possible. Mass exchange and energy exchange, both are possible. That kind of system known as open system. See here again, one vessel. In this vessel, something is filled, gas, something. So it's a boundary real, and it is made by conducting material. So it is dithermic wall. Dithermic boundary or wall, you can say. And here you are providing some kind of heat. Suppose you are providing some kind of heat. Then what happened? Vaporization started, mass decreases. Okay, yes or no? From here, it's a conducting wall. If you are providing energy, if you are providing heat, then liquid start boiling, mass exchange is possible, and energy exchange is also there. Energy exchange can be done by two ways. One is heat and one is work. What is this, sir? Heat I can understand, because you are providing heat, then mass exchange is possible, energy exchange is possible. Higher temperature to lower temperature, heat flow from high to low temperature. But energy exchange, how work related? Not getting it, You will get it. Check it. Suppose one system is given. Okay, later we will discuss. Don't worry, I will tell you. Now come to the closed system. Here only I am telling you. Closed system. Closed system is what? Such a system, mass exchange not possible, only energy exchange is there. That kind of system is called closed system. See, here you have to close this from this. Now heat exchange is going on. What going on? Heat exchange. Heat exchange is what? Energy exchange. But mass exchange is not possible. All the mass will be in this container only. Mass exchange is not possible. So it's example of closed system. Now how related to the work? See, this is a system, and here one piston I applied. Okay, one piston I applied, and here gas, liquid, something is filled. Here pressure of piston, and here pressure of gas or liquid, and this is your insulating, not insulating this time, sorry. So it is not insulating. Now if you are providing energy, if you are providing energy, heat you are providing, then what happened? Piston rises up, yes or no? Liquid will expand and piston rises up, yes or no? Piston rises up, that means work will be done, yes or no? Work done. So this is a energy exchange related to the work. Energy exchange related to the heat is easy, but energy exchange related to the work, by this example you can understand. Now closed system, open system, closed system, isolated. Isolated system, no energy exchange, no heat exchange. This time if it is made by insulating material, adiabatic. Adiabatic means no heat exchange. It's an adiabatic boundary, no heat exchange. So this is the example of no heat exchange, no mass exchange. This is the example of, here also if you, this material is non-conducting, it is not dithermic, it's a adiabatic now. Okay, so this will be the example of isolated system. Okay, so these are the type of system, children. Now we will discuss about, let me erasing it. Now we will discuss about thermodynamics. This is thermodynamics. In this thermodynamics, what are the variable, perimeter, properties, variable, perimeter and properties of thermodynamics. So two kinds of properties are there, children. One is extensive property and one is intensive. Extensive property and intensive property. What is extensive and what is intensive? In the system, in any system, children, two kinds of properties are there, extensive and intensive. So what is extensive? So here we are going to discuss the property and intensive. Today very amazing facts I will tell you. So from beginning to end you have to check the video. So intensive properties are those which depends upon amount of matter, which depends upon amount of matter. Okay, extensive properties are those which depends upon amounts of matter, or you can say depends upon size of sample. Tell me one thing, like mass is what? Depends upon amount of matter. A small piece of rod, big piece of rod. So different mass. Volume, one glass of water, one bucket of water, one bucket more water will come. Number of mole, so many properties are there. Okay, intensive properties are those which depends upon, does not depends upon size of sample, or amount of matter. Okay, these are those property which do not depend upon the size of sample or amount. जैसे like density of one glass of water, one bucket of water, one drop of water, same density is there. Refractive index of glass, children, is same, either not a big glass or a small glass. Refractive index is same, so it's not depend upon the big or small. Specific heat capacity, although the heat capacity is extensive property. Now train came, wait to 30 seconds. So specific heat capacity is intensive property, although heat capacity is extensive property. Now very important thing, concentration terms are like molarity, mole fraction, etc., percentage, mass by percent, weight by volume by weight, etc. they all are what they are? Intensive property. How, sir? See what happens, children. Molarity is what? Number of mole upon volume. Number of moles is extensive property, volume is extensive property. So extensive property upon extensive property is intensive property. Extensive property upon extensive property becomes intensive property. That is why all the concentration terms are intensive property. Here also many examples you can take, like enthalpy, entropy, Gibbs free energy, internal energy, etc. So if I will give example, so only in the example 1 hour will go. Okay, so like that, this is the difference between the property. We'll solve one problem and move for next. See, the question is, which one of the following is which one of the following is extensive property? I think introduction not will be completed in one lecture. It will take two lectures because time I don't have more time this time because lecture is there. So option A is specific heat capacity. Specific heat capacity. Option B gives free energy. Option C electromotive force. Option D dielectric constant. In all these cases, children, check it. Specific heat capacity if you are talking. So I told you formula Q is equal to, sorry, specific heat capacity is equal to Q upon M delta T. Q extensive property, M extensive property. Extensive property upon extensive property, intensive property. I gives free energy, extensive, I told you already. Electromotive force is equal to W upon Q. Both are intensive property, so it will be, sorry, both are extensive. W and Q both are extensive, then electromotive force will be intensive, and dielectric constant is intensive property. Okay, so this is the question. Now so many things are there, but I think it's enough for this lecture. Later we will discuss in the next lecture. So thank you children for the watching. Please support, subscribe the channel. Thank you.